Okay, so now it's the third video, and now it's time to configure the analog to digital converter in scan mode, which will read multiple channels. For my purposes, I'm just gonna choose channel 7 for no reason, just channel 7. So I'm gonna read channel 5 and 7. I'm only gonna do 2, so I'm not sitting here typing code all night long. So here's the code for from the previous video. It's unchanged. So I'm just gonna modify this on the fly so you can see how we can go from this single mode configuration to set up the multiple channel configuration. And again, it helps if you've seen the two previous videos to understand where we're coming from here. So like I mentioned before, in scan mode we are gonna be using the DMA controller, so we're gonna go ahead and enable that. If you look in the data sheet here, let me open up the RCC registers. I'm gonna be using DMA1, so as you can see, this is in the AHB enable register of the clock controller. So we're just gonna go ahead and enable DMA1, and I'm gonna put it right here under where I enabled the well, that's the analog prescaler. I'm gonna put it here with the other stuff, and this time I'm actually gonna go ahead and type it in front of you guys, so enjoy. It's the AHB enable register, and we're gonna go ahead and find this definition. Crap, this is why I don't like typing it, because I'm over here having to search for stuff, so it is what it is. Okay, RCC, so AHB, where are you? APB, AHB, DMA1 enable, here it is. Okay, so we've gone ahead and enabled the DMA. Now next, as you can see, since we're using another channel, we have to configure the pins for our other channel, and I'm using channel 7, and they tend to match, so channel 7 will be pin 7 on the same GPIO port. So I'm just gonna copy and paste that, and it's gonna be pin 7 anyways, on the low register. Let me make sure that is the low register. Actually, I think register low, yeah, pin 7. Yeah, I thought it went up to the second register, but no, it's on the low register. So yeah, so configured the GPIOs. Next, we're gonna have to set the end of conversion interrupt. Well, we won't need interrupts anymore because we're not we don't have to worry about that, because the DMA is gonna handle putting everything into our onto our array that we're gonna make. Set the sampling. Well, now I have to set a sampling rate because I'm using another channel, so I have to set its own sampling rate. I'm gonna use channel 7, so instead of 5s, these are gonna be 7s, and I'm gonna give it the same settings. I just have to make sure it's on that same sample 2 register, because I know there's more of those. ADC registers, sample register 2 has 5 and yep, 7 is on the same sample 2 register, so I'm gonna go ahead and give it the same setting. Okay, so channel 5 and 7 samples are set up. So now the sequence. Okay, so now I know that this sequence register, where the hell are you? I know sequence register 1 has this here, which we left it by default. That's only going to do one conversion, but I know now that I am not going to do just one conversion. I'm going to do two. So I'm going to have to shift a 1 into the 0th bit into the 20th bit actually. So I'm going to shift a 1 into the 20th bit. I'm going to go ahead and do that. I'm not even going to bother looking up this specific what is that, SQR1? I'm not going to bother looking for the specific name of that bit. I'm just going to go ahead and shift a 1 into the 20th bit. So now I'm giving it a length of 2 sequences. Okay, so I've given it a length of 2 sequences by shifting a 1 into the 20th bit right here. 2 conversions. Okay. That means that now I have to go ahead and adjust those sequences because sequence 3, the register 3, I mean, we have the first sequence which we've already set up to be channel 5. So now the second sequence I'm going to set up to be channel 7, and I'm going to go ahead and just shift a 7, the value 7, into bit 5 of the SQR3. So where are we? These are the sequences, right? Yep. Length of sequences, and now I'm gonna go to ADC1, SQR3, 3. Okay. And I'm gonna shift where was it? Channel 7, 7 into the 5th, I believe. So that's what I was thinking. Yeah, 7 into the 5th bit will give me the second sequence. So yeah, so I've shifted a 7 into this 5th bit, telling this that channel 7 is going to be my second conversion here that I want to do. Now we're going to have to go into the control registers of the ADC to set it to scan mode and to set it to DMA. And we're still in continuous mode because I want it to continuously scan. So we're looking at this bit now, which is the scan. I don't even have to tell you, but it's the scan mode enabled, which is control register 1. Where are we? We're over here. We're setting things up. I'm just looking at the code. I want to do this before I enable the actual ADC. So correct. Control register 1. So that scan bit, this one I guess I can define. ADC, yep, ADC control register 1. Oh, scan, there it is. Okay, and now I'm gonna go, I think the other one's in control register 2. In control register 2, what I'm going to find is the DMA, somewhere, DMA right there. So that's in control register 2. There's actually a naming convention that you can, and I always forget to do this. So for example, I know I'm using ADC1. I know this is the CR2 register, and I know this is the DMA bit that I want to set. So ADC1, I know I'm in control register. Oh no, it was control register 2, right? So instead of looking and searching for these defines, what you do is you type the name of the peripheral without the number, right? So just ADC, or it could be UART, or it could be whatever you're doing, just without the number, without saying ADC1 or ADC2. You type it just like that, underscore, then you type the register, control register 2, underscore, and then the bit that you want. In this case, it's DMA, and there's the define. So without having to search through here, I forget. That's why I never do it. Okay, so that's the ADC settings. Now we have to go ahead and Now we're gonna have to go ahead and set the DMA settings, right? And I know I haven't done any videos on DMA, but it's pretty straightforward, so maybe you can get a little insight on how easy it actually is to set this up. So we're gonna go to the and I will do a proper video on it, but for now we can just follow along here. So we're gonna go to the DMA registers. We're gonna go to, where is it, CPAR. This is called channel blah 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 peripheral address register. So like I explained in the other video, the DMA is gonna take the data in the data register, right, of your ADC, and it's going to transfer that into whatever address you tell it to transfer it to. So in this register, the CPAR, which is the peripheral address, channel peripheral address, you're going to give it the address of the peripheral, okay, you know, where's the data coming from. So we're going to give it the address of our data register, right, our ADC data register, because that's where well, that's the peripheral, and that's the address register. So we're gonna give it the data register for our peripheral, and that just, you know, again, I'm using DMA 1 channel 1, so there you go. And we're gonna go to that CPAR, and we're gonna pass it the again the address of our data register. So it's gonna be unsigned integer 32. I'm just typecasting it. I'm not even sure if you have to, but anyways, so we're gonna pass it the address, right? Data register. So right there, I'm just giving it the address of the data register to go into that register of the DMA channel, right? I'm sorry, I know I stumble a lot through my words sometimes. Now the next thing we have to do is, I'm gonna go here into this CMIR, where here it is. So this register on the DMA, we're gonna give it the memory address. So it's gonna take the peripheral address, it's gonna get the data from there, and now we gotta tell it where do you want to store it. Where do we want it to store it? So we're gonna make an array, and that's the we're gonna give it the address of that array so that it can store it there. So let's go up top, and it's making an, and since the data register for the ADC is 16 bits, I'm just gonna go ahead and make this a 16-bit variable. We can call it samples, and I'm only doing 2, so I'm gonna go ahead and do something like that. So yeah, I'm only doing 2 conversions, so we can go ahead and do that. Where am I at? So yeah, so we're gonna give it the address of that specific variable into this CMAR register. Losing myself here. Channel 1 MAR register. And same thing, integer, well, this has to be 32, oops, because the addresses are 32 bits, so in this case it does have to be 32. And when you're passing, when you're gonna pass the address in an array, you don't even have to use the ampersand, because just the name of it will return the address of the first index. So that's pretty cool. Now the next thing we have to do is tell the DMA controller how many transfers is it going to do. So for that we go into this number of data. So how many transfers, basically number of data to transfer. So we're only going to do 2. So we can just go ahead and just write 2 into that register, which is called CNDTR. Now we're gonna go into the control register of the DMA, and we're gonna do some settings. It's only like 3 settings, I think. Here you go. All right, first things first. If you look at this right here, bit 5 circ, it's circular mode. What this means is that it's gonna go through our array when it's done filling it up with data, and when it's doing it all over again, instead of moving on to some other data, it's gonna circle back around. So that's what it means by circular mode. Once it reaches the end of however many conversions it's going to do, it's going to go back around and start filling the array from the top again. So we're going to set that. And what allows it to do that is the fact that we have, where is this? No, not memory. This one, right? No, damn it. Where the hell is it? Memory. Oh yeah, memory increment. So what allows it to do that is the fact that we're going to enable this, which is memory increment mode, where it's going to increment our memory. So as soon as it reads a transfer from the ADC, it's going to put it into the address, right? The very first address. Then it's going to increment that address, and it's going to the next one, and it's going to put it there. If we don't do this, what is it going to do? It's just going to rewrite the same address over and over. So we'd have the same issue that we're having in the first place with the ADC, where it's only one address. So this, in conjunction with this, is what makes it work. The fact that it's going to increment our address, and once it reaches the end, it's going to go back to the beginning. Now, how it knows which is the end is because we set that counter to 2, so it knows it's only going to increment it twice, you know, and then go back to the beginning. Over here, we have to tell it the size of the data that our peripheral is outputting. So it's our peripheral is out, the ADC is outputting 16 bits. So we're gonna set that to 16 bits. And then the size of our variable, or our memory address where we want it stored, obviously it's also gonna be 16 bits. And really, that's all we have to set in here. One thing I do want you to note that I forgot to say, as you can see in the where we put the addresses of our peripheral and our memories, it says this register must not be written when the channel is enabled. Same thing for this. So we're gonna do all our settings, and then at the very end we're gonna enable the the actual DMA. So let's go ahead and do those settings we just talked about. I hate when I do that. Channel 1 CCR or equals. Now I'm gonna go ahead and go to the DMA and look for those defines, so that I don't mess them up. Oh gosh, is it at the top? Oh, there it is. Saw it. Nope. Oh, come on, where are you? I saw the DMA, but those are not the defines for it. Oh, there we go. DMA. We're in control. We're in CCR1. Alright, so we're looking for CCR1. We're looking for the circular mode, which is this one. We're looking for the address, or we're looking actually for this one too, memory increment mode. So we're looking for that. Now we're looking for the memory size and peripheral size, and it's the first bit, so it's bit 0 and bit 1. If you go back to your data sheet here, it says 16 bits. So we're gonna set this is bit 1 and this is bit 1, that's bit 0, so we're looking for the 0th bit in both of these, in M size and P size. So the 0th bit P size, and M size 0th bit. And should do it for that. Now at the very end we can go ahead and enable our DMA, which I think it's in the same controller. Enable, yeah, the 0th bit. I could have just written at the I could have just written it at the end of that previous line, but whatever. There it is. Now that's really all there is to it. Now all I'm gonna do is update this channel 5. So instead of val, I'm gonna have samples index 0, and then I'm just gonna erase this. I'll put channel 5, just erase that, copy this right here, add like a little thing there, and then put this channel 7. So copy and index 1. Right, so I'm gonna print out channel 5, the value in channel 5, channel 7, and the value in channel 7. Compile this, make sure we have any errors, no errors. Upload this. Okay, so now I'm going to turn potentiometer for channel 5. So as you can see, channel 5 went down. Now channel 5 is going up and down again. Now channel 7 has another potentiometer. I'm going to turn that one down. And it went down, and then that go up again, and then turn channel 5 up again. So yeah, so basically that's really all there is to it. As you can see, it's really it's not that hard. It's just sometimes understanding the data sheet, and you might miss little things like, you know, don't set this register while it's enabled, because, you know, your freaking microcontroller might blow up. So you might miss little things like that. I know I did, and it didn't. It was behaving weird. So or you might forget to enable the clock for it or whatever. But anyways, guys, that's it. I hope you enjoyed it, and I think that's gonna be it for the analog to digital converter. Actually, I might implement that that watchdog event, but I mean, it's really it's kind of nothing out of this world. It's just you're giving it a high, and let me show you guys the picture of it. What the hell are we? ADC main features. Does it talk about? Or does it talk about the damn watchdog? I don't know. Maybe I'll just do a video on it. So yeah, that's all the watchdog is. It's, you have your analog value here that's gonna vary, right, between 0 and whatever, and you have two levels: a high level and a low level. And as it's, you know, whatever it is that you're measuring, once it goes past this level that you define in the register, it'll give you an interrupt. Or once it goes below a certain another level, it'll give you an interrupt. That's all it is. But anyways, guys, let me know if you really want to see that implemented. Otherwise, that's about it for this ADC series. It's not that complicated of a peripheral to use. And if you have any questions, again, let me know down below in the comments.